Dear student, today we have a new tricky question for you. This is chain rule. We are trying to prove it. Let's come. We start. If y is a function of f of u and u is a function of g of x, how we can find the chain rules? According to the definition of chain rules, we are finding dy by dx derivative with respect to of the y function is equal to dy divided by du, because another function we have taken u is a function of g of x and dot du divided by dx. But du are cancelled to each other, so we get the original dy divided by dx. But we cannot cancel to each other, but we try to taking the derivative. This is considered the first function and this is considered the second function, and we are taking again derivative of this function dy by dx. Dy by dx is equal to dy by dx is dy by du and du divided by dx. So it's consider u first function and this one is considered to the second function. This is equal to dx. This will be dx. Now according to the proper rule, here d and d we are multiplied to each other, their power will be 8 in here dy by d, and similarly in here power is 1 and power is 1 and dx square we can write. Similarly, and here we are using the product rule. The first function we left the first function and we are taking the second function derivative dy by du and derivative of the second function with respect to u du divided by dx, plus in case of multiplication this is considered first function and second function we left dy by du and taking the derivative of this function, plus and we leave this question in here du divided by dx and the derivative of the first function dy divided by du. Now look here d and d are also multiplied according to the rule dy divided by dx du and dot this will be equal to d square u and here is also one dx square plus, but and here we can du divided by dx. Here is d and d is also multiplied, we get d square and y, but in here is the situation is different and here the situation is different. We cannot add because in here is x and there is u, so we can write this one dx and du. Now this problem we can solve in by dx into d square u divided by dx square plus du divided by dx. But the problem is this one. Now we change and here this term of replace of this term we can write this term d square y divided by and here this term if we are multiply du and divided dx and du divided by du both are cancelled to each other. But now we are interchange this result. This is du both are cancelled to each other. We try to make and here the same term dy by dx and d square u divided by dx square plus du divided by dx. This term we can interchange this result, so d square y and this will be equal to du square and here du divided by dx. Now this term and this term are same, we can write dy by dx d square u divided by dx square plus this term we can write du divided by dx whole square, because we are add their powers to each other, and d square y by du square. Now the second result of this function we can write y d square y and dx square is reduces in the form of now how we can write this one y double dash. According to the definition of this is double derivative, and this one is the single derivative y dash, and this will be u double prime, because this is double derivative, and here is first prime is square dot, and this will be y double dash. Y double dash, we get the result is, this is the chain rule. Now if we replace the u result is in this function, what will affect the results? And u double dash plus u prime whole square and y double dash. Now we want to check by another method this one. Now if we replace this function in the place of u, so y is equal to f and u is a function of g of x. In the place of u we put this. Now differentiating on both sides, so dy by dx is equal to, so we can get in here the derivative with respect to x. If we are finding this result, so the result will be f dash g of x in further derivative of this function dy by d g of x. Now this will be dy by dx is equal to, we can write this run f dash g of x, and this is also we can write g of dash x. Now again we are differentiating, we are taking the second derivative, we are finding dy by dx is equal to dy by dx f dash g of x and g dash f of x. Again we have get the product rule, we are y, and here is ds we get dx square. Here we are using the product rules. According to the product rules we are left this function f of g of x and derivative of first function plus and second function we remaining in here, and derivative of the first function f dash g of x. Now so we f dash g of x and derivative of this function we can write g double prime of x. Similarly, and here we can write this and double prime of this function f double prime of g of x, and now and further of the of this function we take g of x. Now f dash g of x and double derivative of g of x and first derivative of g of x and f dash g of x. Now we can write this one as g of dash x. Now g of dash x, g of dash x is same, so we can write f dash g of x and double dash g of x plus and g of dash of x whole square, because both are same we add their power, and f double dash g of x, which is the required result of comparison of this result. So this result is equal to y double prime. So y dash and double prime and u dash, in the place of u we put g dash of x square and y dash in the place of double dash. Both result are same. Thank you very much for watching. Please subscribe my channel. Thanks again for watching.